jawab, you pergi next soalan. You tak dapat pergi back. So make sure bila you jawab tu, that is your final answer. Okay? Because share quiz you 15 minit, 10 soalan. MCQ. Okay, kalau semua dah ready, nampak tak lecture slide? Okay, nampak. Okay, good morning everyone. You guys boleh buka video tak? Buka video. I nak cover topik on recursion. Recursion ni satu topik yang kita pernah belajar dululah. I think you guys are quite aware of recursion. So recursion tu apa? Saya ingat you dulu. What do you remember with recursion? Dayang Narira. Apa tu recursion, Dayang? What is a recursion? Mana Dayang Narira?
Solving a problem by reducing it to smaller.
Okay. Okay. So it's a function that calls itself back lah. But when it calls itself back, dia punya apa tu? Problem tu dia kecil kan. Sampai satu tahap dia akan jumpa dia punya base case ya. Base case dia mesti ada solution pada tahap yang asas dia. That's why dia panggil base case. Alright, so there is a solution at the end. Alright. Not a solution, rather an answer. Okay, so that is called the base case. So basically it's usually a function that calls itself. So you're gonna learn what is basically a recursive. Alright. Then you're gonna look at base case and general case. Alright, and then we're going to look at a recursive algorithm. What is a tail recursive? What does it mean? Then we're going to look at what is a recursive function, and then how you implement recursive algorithm. So nanti you have to ask yourself, recursion, recursive solution, okay, solution yang based on recursion dengan normal iterative solution, which one is better? Linear solution and recursive solution, which one is better? Okay, so you have to ask yourself this question later on. Okay, the answer is there. Later on I will inform you lah. But for now you should ask yourself recursion dengan linear. Linear tu macam straightforward lah. Straightforward implementation. Okay, so you don't go towards reducing the problem size. Okay. So recursion is basically solving a problem by reducing it to smaller version of itself. So basically a function called itself back, but when it calls itself back, right, the problem space gets smaller. Usually it's done by adjusting the parameter lah. The parameter gets smaller, so it reduces the size. Okay, it's a powerful way of solving a problem, which can otherwise be complicated. All right. It provides an elegant and powerful alternative to performing repetitive tasks. Why repetitive? Because the function to call itself. So it's repetition lah kan. Dia panggil diri dia balik. So, what is a recursive definition? Basically, it calls itself, but when it calls itself, it's a smaller version of itself. Okay? So every recursive definition, you're going to have a base case, and then you're going to have a general case. All right. Base case is usually where you got your some form of simple solution, the base case. Right. General case, you reduce. It's going to basically general case you will reduce your size. That at one point it will reach the base case, and the base case you have the solution. All right. So recursive function, basically a function that calls itself lah. But every time it calls itself, it reduces the size. It reduces the size, eventually it will reach the base case. Itu konsep dia. So in all the lecture note, you must understand the concept. That one is very important. Maybe after lecture, you understand 50% lah. If you don't understand a lot, at least you understand 50%. But what is important is that the concept, you must understand 100%. Okay? Dayang, okay Dayang? Tak apa, saya jawab. Just put thumbs up pun cukup lah. Alright, so I understand that you guys understand, okay? Naim, okay? Okay, ya. Kalau faham, put thumbs up, ya. And okay. Now, ini kita tengok ni factorial. What is 5 factorial? 5 is basically times 4 factorial. 4 factorial is 4 times 3 factorial. 3 factorial is 3 times 2 factorial. Basically, you see, problem size tu kecil. Tahap last. See, 5 times 4 factorial times 3 factorial times 2 factorial, 1 factorial, you always have the answer, which is 1. So that would be your base case. Okay? So, 1 factorial is basically 1 times 1. Why? Because 0 factorial is 1 already. Okay? So, 1 factorial be 1 times 0 factorial. 0 factorial is 1. Okay? So, once you get 1 factorial, you can answer 2 factorial. Once you get the value for 2 factorial, which is 2, you can answer 3 factorial, 4 factorial, then finally you can answer 5 factorial. So it reduces the size until you sampai kat base case ni. Then you can answer, then that answer will be fit onto the previous problem that could not be solved until it solves the larger problem. Tu je konsep dia. Okay, who don't understand, please ask me now. Because this is the basic concept, you have to understand the basic concept. If you don't understand, please ask me now. Semua okay, yeah? Alright. Okay. Now, say lah. Okay. First question is, what makes it factorial? Itu nombor 1. Vanessa, what makes it factorial? Ayo, tak dengar lah Vanessa, mic you off. You can on the mic. Ayo, I cannot hear. Sorry, Vanessa. Cannot hear you. Dayang? Nak try Dayang je kena. Sorry lah Dayang. Muka you kat depan skrin ni. Tak apa, try sikit boleh Dayang. Nak test je. You faham tak dia basic concept? It's okay kalau salah, tak ada masalah. Apa yang buat what makes it factorial kat sini?
The factorial is the number until 0.
Oh, okay. Alright, ya.
Until smaller number.
Ada betul. Ada betul-betul okay lah 50% lah Because why you see? First, it calls itself back. Tapi you kena jawab lengkap tau. Jadi bila dia panggil diri dia, you see ada return here kan? When it calls itself back, it reduces the size of the general case. Alright? And when it reduces the size, it will finally reach a base case. This is a base case. So we must fulfill this criteria here. Okay? It has a base case. The base case will stop the recursion. General case must be reduced into the base case. Alright? So, this is whereby it calls itself, but it reduces the size. Okay, and finally, it will reach the base case, and the base case will stop this function. Okay, now, if you pass 3 as a num, so factorial 3 here, num would have the value 3. Okay, num is not equal to 0. Therefore, it will go to this statement here. It will be 3 times factorial for the function here, 3 minus 1, which is 2. At this point in time, it cannot be solved. Because you don't know what is the answer for fact 2 here. So, pergi balik, masuk dalam ni. 6 jadi 2. Okay, 2 is not equivalent to 0, so it returns 2 times fact 2 minus 1, which is factorial 1. Still cannot solve. You don't know the answer for factorial 1. Masuk balik. Now, 1 is not equal to 0, then return 1 times factorial 0. Okay, dekat sini dia tak ada answer lagi. Naik atas balik, panggil balik. 6 dapat value 0 kat sini. Now, 6 baru sama dengan sorry. Okay, now 6 is equivalent to 0. So, bila 0, you get the answer. Return 1. Now, when return 1, so here, dekat sini fact 0 ni, the value is 1. So, 1 times 1 is 1. So, you return 1 balik. So, here you get 1. 1 times 2, you get 2. So, you return 2 for this one here. This part here, you got 2. 2 times 3, 6. So, you return 6. Okay? Any questions? Okay, no questions. Okay, no question, there's two types here. This is a direct recursive function. This is indirect recursive function. All right? A function that calls another function, and then it results in the original function to be called again. This is called direct recursive lah. Okay? Oh, sorry. A direct recursive function is basically a function that calls itself, period. Okay? These two is basically an indirect recursion. Okay? So function calls itself is direct recursive function. This is a direct recursive function because it calls another function. All right? And then finally it calls back its original function. So you see, function A calls B, then B calls back A. So indirect. Okay? This one, function, so D calls, sorry, it should be A calls B, B calls C, C calls D, then D calls back A. Alright, so this is an indirect recursive function. Now, tail recursive function, alright, is a recursive function whereby the last statement executed is the recursive call. Okay? Now, you see this one here? You have factorial, and then you have written x times factorial. Okay? A recursive function in which the last statement executed is a recursive call. Alright? So, now I want you to think for 1 minute. In this particular example, is this a recursive, is it a recursive function? Okay, ask yourself, is this a recursive function or not? That's number 1. And then number 2, is it a tail recursive function or not? Okay. Look at the code, think for 1 minute. Okay. A tail recursive function, okay, is basically a basically the last statement executed by the function is a recursive call. That is a tail recursive function. Okay. So this one here, is it recursive or not? It's a recursive because it calls itself back. Nampak tak? Right? X minus 1. So it's a recursive. Now, is it a tail recursive function? It calls itself back, so it's definitely a recursive function. Now, a recursive function is basically the last thing executed is the function call to the function itself. So you call it at the end. So here, you see, it's a recursive function, but is it a tail recursive? A tail recursive function, last statement executed is a recursive call. Here is recursive call, but you also have a multiplication over here. Okay, so because of that, this is a non-tail recursive function. Because dia ada multiplication. So this one you see, it is basically the last statement executed is the recursive call. No multiplication, no nothing, just the recursive call. So the last statement, dia kena ingat, dia punya rule is the last statement is a recursive call. So this is a tail recursive. Last statement is a function that calls itself back. Now have a look at this one. Oh, by the way, you got any questions regarding the difference between these two? Understand or not? Okay, ini betul recursive, they call itself back, tapi dia ada multiplication. So it's a recursive, but it's a non-tail recursive because of this multiplication. Kalau tail recursive, dia mesti just the function call itself back. Okay, macam ni, dia call itself back, tapi dia kurangkan the size recursive. Alright, it's the last statement call. Now this one, is it tail recursive or not? Oh sorry, ada question dekat chat, saya tak perasan. Okay, no, okay, alright, no answers. Okay, Kevin Wong, where's Kevin Wong? Kevin Wong, what are you, Kevin Wong? Oh, tak ada mic. Okay, Venorika. Is this tail recursive, Venorika?
No. No, it's not tail recursive.
Tak dengar lah, Venorika. Is it tail recursive?
No, not
No.
tail recursive.
Why is it not tail recursive?
Because there is already a recursive call there.
Yeah, betul. The function call, you see, this is the first one. So the function call is not the last one, because dia ada yang ni. Dia kena tail recursive means dia tak tail lah. So when you call the recursive, it must be at the end. Put it that way, simple. Imagine the animal got a head and tail, right? The tail is only at the behind. So when you tail recursive means the recursion must be only at the end. Like this one tak boleh, dia ada dekat head juga in a way. Okay? Hope that's clear. There, already explained for you inside your slide. Alright. So infinite recursion basically will execute forever lah. Alright. But obviously there's nothing executes forever. So the limitation will be your computer memory running out. Because you see, bila you tak habis the partial solution, you keep the data or the state inside the memory. Tak habis, keep your memory. Tak habis, keep memory. So at some point, your memory will habis. Betul tak? Okay. So it will stop usually when it runs out of memory lah. Okay. Now we're going to look at problem solving using recursion. The problem we're going to look is finding a largest element in an array. Print a linked list in reverse order. Ingat linked list kita dah cover last week. And Fibonacci number. This one is a mathematical equation. Alright. Now largest element in array. Okay. Conceptualize. Index 0 to index 6, you have all these number. How do you find the largest element in array? Alright. So these are the different scenarios lah. If the length of list is 1, then the list has one element. Alright. You imagine. Kalau you nak reduce ni, okay, Venorika. Mana Venorika? Are you there? Oh, Venorika out. Faris. Venorika ada. Okay, Venorika. You imagine, kalau ini recursion macam mana rupa dia, Venorika? Jadi tengok gambar ni kan. See this picture. You imagine lah your head. Okay, recursion, what does recursion do? It makes it into a smaller piece. So how does it make into a smaller piece? Imagine ni sebuku roti. You potong, betul tak? Kan, sebuku roti dah dipotong. So, macam mana nak reduce size? Macam mana you nak reduce size roti tu, Puan Norika? You makanlah roti tu kan? Betul tak? You makan the roti, reduce the size lah. So, you makan ni, makan, sampai you tinggal satu. So, satu tu jadi apa? Dayang. You guys kena fikir. Macam mana tu? You dah ada sebuku roti, dia dah potong, you makan. So, satu tu akan jadi apa?
The largest element.
Mana dah elemen? Tunggulah dulu. Wah, come on, fikir. Faris, become what Faris?
Dia punya tu
Apa? Fikir. You reduce the size,
ha?
pap, sampai dia mesti ada solution, betul tak? Bila you reduce the size, dia mesti sampai satu tahap tu ada solution. Dia panggil apa?
Recursive.
General? Apa dia? Tak dengar, sorry. Tak dengar, Faris.
Value.
Dia jadi, dia start dengan letter B.
E.
Base case.
Oh.
You guys. Jawapan di depan mata.
Sorry,
Okay.
belum loading.
Tak apa. It's okay. Alright. So, okay. So, the list has one element. Okay. So, you just keep in that inside. Okay lah. If the length of the list is 1. Alright. That means the list has one element. Then that would be the largest element inside the list. So, bila potong, tinggal satu, that will be the largest element in the list. At that moment. Ingat tak bila kita cari maximum, ingat tak last semester we belajar ITP, you want to find a maximum number kan? Imagine that you make an assumption, the first number is the biggest for now. But when you compare that with the second number, if the second number is bigger than the current maximum, then that new number will become the maximum. You remember that one? The same concept applies. Cuma dia reverse order je. Kalau dulu, the first one you jumpa, yang ni cakap bila you potong, tinggal satu, then that is the maximum lah. Logik lah, betul kan? Kalau you dah tinggal satu, itu je nombor, itulah paling maksimum, betul tak? Think about it, the logic. You got only one number, then whatever, you dompet ada RM1. Dan berapakah amount yang terbesar dalam dompet anda? RM1 lah paling besar, betul tak? Kalau RM10, RM10 lah. Okay? So, balik pada cerita, with the length list of 1, ni where Dayang got a bit confused just now. Then the unique element is the largest element in the list for now. Okay, for now. If the length of the list is greater than 1, then to find the largest element in the list, find the largest element in A plus 1 till B. But the real list is A. Nampak tak? Okay. Bila you find the largest element, it is A plus 1 to B. Ini semua adalah A. Semua ni. A plus 1 is this fellow here until B here. Nampak tak? So, pas adalah semua. Kemudian dia akan A1 hingga B. Satu A1 sini pula jadi B. A1 sini pula jadi B. So kecil, last sini jadi paling besar. Tapi dia tak habis lagi. Because ini recursive. Dia partial solution. Okay. So, base case, the size of the list is 1. So the only element in that list is the largest element. Ingat ya. So I already explain. Potong roti you makan sampai habis, tinggal satu. Itulah yang paling besar. Okay, itu number 1. Solve base case. Semua faham? Tak faham, tolong tanya sekarang. Kalau saya sampai sini, saya tak nak ulang. Kau dah panjang dah. So, saya tanya sini dulu. Faham ke tidak? Semua faham? Karin, you senyap. You faham ke tak Karin? Rebecca? Karin Chong is the same person? Rebecca. Okay, Rebecca, you faham? Okay.
So far still okay. I think the concept.
This konsep okay. Saya dah terangkan kat base case ni tadi. Ini faham tak kenapa dia satu saja? Why the one size of the list is 1 is the largest element. Faham tak? Into that part first.
Is it because that's the last one?
Ya, betul. That's the last one, betul. Because you dah reduce lah. Kecil kan. Macam you punya dompet lah. RM10, you keluar RM1, then the last one, that's the biggest one lah. Okay? Ayo, wait lah, sorry. Ada phone call. Okay. Hello? Oh. Sorry. Alright. Okay. Now, the general case. This is the exciting part. The general case. The list size is A. Okay? Tapi when you want to find the largest element, this is where it gets weird now. You find it from A plus 1 until B. And call it max. A plus 1 till B. Okay? So to find largest element from A to B, you're going to find the largest element in A plus 1 to B. And then you call max. Okay? Now, you compare the list of element in list A and max. If list A is bigger than max, this is where your ITP comes in. If it's bigger than the current max, then this list A will become the new max. Okay? Otherwise, the largest element in list if list A is bigger than max, the largest element in list A and list B is list A. Otherwise, it will become list A to list B is max. Okay? Now, have a look at this code lah, right? This code here. So, if list lower index is bigger than the current maximum, this list lower index will become, okay, this one you will return this as a list of the lower index. So what is list lower index? It's list A plus 1. Alright. So if list A, okay, is bigger than the current maximum, alright, the largest element in list A to B is list A. So when you say about list A, it depends actually. Because you see, this one is actually a recursion. It calls itself back up. Nampak tak? This guy here, dia punya lower index value ni, okay, it actually depends. Because when you return this list lower index, you call itself back up kat sini. Bila you buat max ni, lower index plus 1 and upper index, okay, it is basically calling itself back up. Okay. Otherwise, the largest element in list A to B is max. Okay, so you return max. So you have a look at the code here. Okay. Largest list 0, 3. Okay, so 0, here 3. So this is the lower index, this is the upper index, this is max. So we have a look here. Okay, this is the array. Array is list, lower index and upper index. Lower index is 0, upper index is bigger. Okay, find the max. So when to find the max, you don't know what's the value for now. Okay. And then it says, okay, if lower index is equivalent to upper index, is it equivalent? No. One is 0, the other one is 3. So not equivalent. Then you're going to else. When you are at else, this is when the partial solution comes in. Because you cannot finish it straight away. Your max now is largest list, same name, list, okay, lower index plus 1 plus upper index. So if it's 0, it becomes 1 now, and 3. So this is where I say just now, okay, the size is reduced. Dia tambah satu lah, betul lah dia tambah satu because dia array kan. So sini daripada from 0 to 3 dia jadi 1 to 3. So it reduce the size really. You guys see that? Okay. Now bila 1 to 3, okay, do you know the maximum? You don't know. You only know the maximum actually when lower index is equivalent to upper index. Okay? Because then only then you get the base case. So here, what is the max? You also don't know. Dia pergi dekat else. Largest, least. Now, if tadi is 1, 3, now it become 2, 3. So sort go here. 2, 3, lower index 2, then upper index is 3. Is it the same? No, it's not the same. So you cannot solve max juga. So you go 2 plus 1 become 3. So least 3 and 3. Now least 3 and 3 you go down here. Now lower index and upper index, is it the same? Yes, it's the same. So you dah dekat sini lah. Okay. So if lower index equivalent to upper index, return the list of lower index. List lower index, so list index 3. So it is 8. Okay. So bila naik sini kat sini 8, so your max is 8 lah. Dia satu je, dia seorang sekarang ni. So dia the biggest lah, so 8. Okay. Now, bila dia dekat sini, 8 ni, dia compare. Okay. Now, because, so here, dekat sini, max akan jadi 8. Now, if least lower index is bigger than the current maximum, okay, return least lower index. So, lower index dia dekat sini apa? Lower index dia adalah 2. Index 2. Okay. Lower index dia, see this guy here, if least lower index is bigger than the current maximum, then return least of lower index, else return max. So lower index is 2. 2, the value is 12. 12 and 8, which one is bigger? Of course 12 is bigger, betul tak? So 12 is bigger than 8. So here you will return the value 12. Okay. Jangan confuse dengan yang ini ya. Yang ini max largest ni adalah 8. Tapi 8 ni is not finished yet. Because you have to do this code here. So here is 8. Least lower index here is for 2. Value is 12. So 12 is bigger than 8. So bila 12 is bigger than 8, you are going to return least lower index which is 2. So bila least lower index is 2, it is basically the value 12. So you return 12 masuk dekat sini. Maximum dekat sini, the value adalah 12. So 12 ni, you have to compare it again. Now, maximum is 12. Least lower index is, least lower index for this one here adalah 1. 1 is 10. So if 1 is 10, so dia ini 10, ini adakah ini lebih besar? Is it bigger than 12? No. So it will return the current maximum. What is the current maximum? 12 again. Okay. Now least 1. Index 1 here is 10. Okay. Lower index ni adalah 10. Okay. So you bawa balik 12. You return 12. Dekat sini. Okay. Oh sorry, lower index sini adalah kosong. Sorry. Kosong. Okay. Lower index sini adalah kosong. So you return 12, maximum is 12. So lower index sini adalah dekat index kosong, so it is 5. So 5, is it bigger than 12? No. So you return max is, so the current maximum for this one is 12. So you will return 12. Any questions? Okay. So yeah, buat susah faham sikit is because this algorithm is not straightforward. You would expect lah inside your mind. You would expect inside your mind when list A is bigger than max, so you return max lah. Macam you punya ITP lah kan. Betul tak? If a number is bigger than the current maximum, that number becomes the maximum lah kan. Imagine, you ada 12. Maksimum you sekarang 8. So bila 12 lebih besar daripada 8, maka nombor tu sepatutnya yang paling besar lah. Tapi recursive ni lain sikit. Bukan lain sikit lah, dia terbalik. If tak fulfill, baru dia return max. Nampak tak? Else, dia akan compare the next index. Because why? Dia partial solution. Dia return max tu akan compare dengan the previous partial solution. Itu yang student selalu kurang faham dengan itulah. Dia tak direct macam you punya ITP, straightforward answer. Because the recursive code, the partial solution. Okay, clear? Ngawang, okay Ngawang? Are you okay Ngawang? Alright, okay, good. Letak thumbs up so saya faham. Okay. Any questions? No questions, saya pergi kat link list. Link list ni senang lah. This one very straightforward. Okay, now link list ni first 5, 10, 15. So kalau you nak print backwards macam mana? Benar Rika, macam mana nak print backwards? First pointer points kepada 5, 10, 15. So nak print backwards macam mana? You nak guna pointer apa?
Backward.
Apa dia? Which pointer can you use? Kalau tak dapat jawab tak apa, saya pergi ke orang lain Okay, tak apa, it's okay. Rebecca, which pointer to use? You nak print dia backwards?
I don't know.
Don't know, tak apa. So, okay, don't know, tak apa. Dayang? Pointer apa nak guna? Lepas ni fikir, everyone think Korean actor. After this, you give your answer as well. What pointer do I use to print it backwards? Backwards mean 15, 10, 5 lah. Dayang dulu. Pointer apa nak guna?
Tak pastilah, sir.
Tak pasti. Okay, tak apa. Okay, what's it? Korean. Kevin. Kevin. Forgot Kevin. Macam mana Kevin? Ada idea tak? Apa pointer nak guna ni Kevin? Nak print pada belakang kan? Agak-agak lah. Your best guess. Tak dengar lah Kevin, sorry. I cannot hear. I think your mic not working Your mic not working Kevin. Tak apalah. Okay, the answer is tak boleh lah. Because you tak ada pointer ni. Nampak tak? Pointer first mesti if you move first, then you tak dapat apa ni? You tak dapat access 5 ni. Tapi first pointer masuk with first point to the first node pun. So how do you do it? What you can do is use partial solution. Okay. So to print a linked list in reverse order, okay, you cannot use the first node. Okay. You tak boleh print second node. Okay. Wait, let's see. Okay. So you kat sini kan. Okay. So first pointer point to the first node. Tapi you nak kena access in order for you to print out 10, you must print out 5. Because you can use first pointer. Okay. Tapi in order to use first pointer, in order to print out 10, you kena print out 5. In order to print out 15, you kena print out 5 dengan 10. Which really doesn't work lah. You have to print out 15 dulu. Kan? So, macam mana nak buat tu? Alright. So, what you do is, macam roti tadi, you know? This array here. Potong, lalai tinggal kat sini. Nanti you print out yang last one. You think about it, betul tak? Sayang, cuba fikir. Sama konsep ni. Andai kata, if this is a roti. What is it? This is a roti. Kira ni satu roti, satu buku. You makan yang ni, tinggal yang ini. Then you print yang ni dulu. Then baru you keluarkan yang ni. Okay? So how do you do that one? Partial solution, final solution, print ini. Bila dah print ini, baru print ini. Dan baru print ini. Think about the logic. Betul tak? Makan, tinggal yang ni. Okay, ini keluar. Then keluar ini. Then keluar ini. Alright? So when you consider tail of the node, you reduce the size by 1. Alright? Eventually, you akan reduce it to 0, whereby you basically reach null lah. So bila you reach null, you print out nombor tu. You see the logic? Simple tak? I pergi sini, I tak print ni dulu. I cakap I reduce the problem size pada yang seterusnya. Sampai sini, tak sampai null, I tak nak print dulu. I akan pergi sampai I jumpa null, baru I print out yang ni. Bila dah print out yang ni, baru I solve this one. So, base case dia, when list is empty, no action. Okay? If list is not empty, print the tail dulu, then only print the element. Alright? So, if current is not null, okay, if this one is not null, then you don't print dulu. You pergi function reverse print current link. So, bila kat sini, if it's not null, you pergi function lain dulu, okay, which is reverse print. Yang when this is finished, only then you will print out this one. You faham tak? Is it? I will reassure it is not null. Okay, so I'm going to call another function. But only that when I call that function, only then I print out this value. See? So what is reverse print? Reverse print says, if current is not null, as long as current is not null, okay, reverse print current link, see out current info. Okay. So, is current null? No. So, reverse print. Is current null? No. Reverse print. Is current null? Yes, it's already null here. So, bila null, okay, bila dah null, dia dah null kat situ, reverse print, dia dah masuk dekat sini tadi kan, dia dah dekat null. So, what do you do when it's already null? See out current info. Okay. So current info, current kat sini, info dia adalah 15. Bila dia dah solve 15, you go to the previous one, 10 and then finally 5. So you have a look at this one here. Reverse print, first current is 5. Is current not null? Because its current is not null, it goes to current link. So current link goes to 10. Okay. Is 10 null? No. Reverse print, current link, go to the next one. Now, is current null? No. Go to the next one. Now, link here dah jadi 0, null. So, bila null, okay, control goes back to the caller. So, when it reaches null, kat sini kan, so this one tak execute lagi, betul tak? The last one. When it reaches null, this one reaches null, it doesn't fulfill this condition if lagi. So, bila tak fulfill ni, control pergi balik dekat sini, turun dekat sini. Current menunjuk kepada info sini, last one, current info sini. So, you print out 15. Then, you print out 10. Then, finally, you print out 5. Okay? Any questions? Okay, I give you 1 minute. You have a look first. Okay? Okay, I give you 2 minutes lah. This one and this one. If you go answer, please ask me now. After this masuk Fibonacci, lagi susah. Dia ada pakai 2 calling function. This one single senang, satu je. Setiap kali, every time you only call 1. call 1. This guy also call 1 time. Fibonacci later on, susah sikit. Because why? You see, it calls 2. 1 and 2. So you get this one. So better ask me now if you tak faham. I give you 2 minutes lah. Kalau yang faham tu, you boleh pejam mata. Kalau yang lain nak pergi bathroom ke apa, boleh juga. But come back in 2 minutes. 11:51, I resume. Kalau faham nanti tolong letak thumbs up. Tak faham letak thumbs down. I just nak tengok. Okay, another 1 minute ya. Ibnu, boleh buka you punya kamera tak Ibnu? Amir, Nasatra. Because I'm a bit worried when students don't open camera. I don't know whether you are in class or you just open and then you go somewhere. Okay, 11:51 dah. Semua okay?
So can I ask a question?
Yes, Rebecca, yes.
For this recursive thing, so does it mean that when, so can you go back to the code slide?
Slide berapa?
Slide that got this code, the code of this.
What slide?
I think it's on slide 24.
24 ini.
Yeah, if it's not null, if the current is not null, then it will go to the next link. And then when it goes to, and when it is, when the current becomes null, let me try to formulate my question.
If current is not null, it doesn't execute anymore. So it doesn't go this one, it returns the call back to here. It returns. So this one, this is a function call to this one.
Oh, so it stopped there. It didn't go to the C out there, huh?
No.
It's not now. So,
No, not that. You see, the C out here is actually, kalau you perasan lah, this C out here, if current is null, then you go into your reverse print, current link. So you see, reverse print kan, okay? You're going to print out all up here to current link. Now, when current is null, okay, control goes back to the caller. So this one is basically, if you see current info here, you see this thing is 2 different code tau. This current info, basically, it prints out nothing kat sini. This one current info and line. So, here, if current is equivalent to, is not null, you're going to call the reverse print. You're going to need to call this function again. I mean, sorry, not calling this function again. You're going to move to the next node. Okay. Then here, you even go back to the next node. Okay. Now here, when current is null already, if current is null, okay, it wouldn't execute this code anymore. it will go back up here, the call.
But that one still got the if current is not null.
Current is not, current is not null lah. So here, you see, if you had 15 already, right? You dekat 15 ni, this current is null. Okay? So you go back to the caller. So remember, this one is a partial solution, yeah? So if current is null dekat sini, okay, it goes back, basically it goes back up to, remember this one, reverse spin here, okay, to this control, this one here. So it prints out the current info. So here, it does not fulfill, okay, it goes back up, okay, to here, and then only you print out the 15. Okay, then you return back to which is 10, and then finally 5. Is it clear? Okay, maybe, okay. Let me think. I think Rebecca's confusion here. Okay, now if you look, okay, first of all, you have to understand, yeah. Now, this one here, as long as current is not null, this reverse print falls to this one. Okay, but at the end of the day, okay, bila you don't fulfill this condition anymore, it goes to a partial solution of reverse print. Perasan tak? Because it's recursive. So it keeps on moving here and then finally here. Because it's not finished yet at the first node here. Mula-mula tak habis, dia pergi second node dulu, dia pergi third node dulu. Okay, bila dah sampai dekat null, this one is no longer fulfilled. Okay, dia tak fulfill ni lagi. Then dia pergi dekat C out. You print out the value. Okay, so you get the 15. Then only you go back the 10, and then finally you get the 5. Okay?
Okay, I'll digest that for a while.
Apa dia?
Okay, I'll digest that.
Okay, alright. How about that? Okay. Maybe you try and draw it lah. Dekat every time dekat sini. Because this one is in word kan. You try to draw it out first. So if you see this one, be careful lah. This one is not the outcome yet. This is the final outcome. So you see, C out current info, print 5. So here, it basically print out 5 here. So this is the outcome. Just be wary of this one lah. This is the outcome. This is the outcome. This is when it actually reaches null. So now here no outcome because you didn't fulfill this condition. So it returns back to the caller. Okay. Okay. We'll have another look at another example. This one is Fibonacci number. So Fibonacci number is basically the maths part. I'm not going to explain lah. We're going to just have a look at the example here. So Fibonacci is basically a sequence of number 1, 1, 2, 3, 5, 8. So this one I think you already covered in your discrete mathematics, right? Okay. 8 is basically 5 plus 3. 5 is basically 3 plus 2. 3 is basically 2 plus 1. And finally 1 is 1. So here, if you notice, there's basically when n is 1 and if n is 2, okay, A will be, okay, first one, if n is 1, is A will be denote the first Fibonacci number. If n is 2, B will be the second Fibonacci number. So like for example, 2 is 1 plus 1. This is your A, this is your B. Okay? And n denotes the number of Fibonacci numbers. Alright? Okay. So if n is equivalent to 1, that means one number, you return A. If n is equivalent to 2, you're going to return B. So this is the A and B lah. Else you're going to reduce the problem size. So here, the Fibonacci is basically 4 Fibonacci numbers. Okay? So 4 here, okay? Now, is n equal to 1? No. Okay? Is n equal to 2? No. So, you're going to return Fibonacci 2, 3, okay? But this n here, you're going to reduce the size by 1. So, you get 3. Here is R, fib number 2, 3, 4 minus 2. Okay? No solution yet. This is a partial solution. But here, this one here, Fibonacci 232. So here, A is 2. And then B is 3. Okay, and N is 2. So if you look at the Fibonacci here, Fibonacci number here, you're going to have the value 2, 3, 2 here. So if n is equivalent to, now your A here, okay, A is 2, B is 3, n is equivalent to 2. Now if n is equivalent to 1, so it doesn't fulfill this condition, n equivalent to 2. So 2. So you return B. So what is your B? Your B here is 3. So you return 3. So here you have a solution already. Okay, but it's not finished yet. Because why? You haven't solved this part here. So when you want to do this part, you're going to get 2, 3, 3. So A is 2, B is 3, N is 3. So this one is cannot be solved first. However, the next one is R Fibonacci 2, 3. Now N 3 minus 2. So 1. Okay. So here, if you go 1 here, pasal dia akan jadi A is 2, B is 3, N is 1. So when N is 1, you return A. So you return 2. So this one you get a solution ready. Then you do this one here. 2, 3, 2. So 2, 3, 2. You go down here, Fibonacci is 2. Oh, okay, so it returns B. So you get 3. So 3 plus 2, you're going to be able to return 5. So the value here is 5. And then here the value is 3. So 5 plus 3, you're going to return the value 8. Alright? But the concept is still the same lah. You reduce the problem size. And then you get partial solution until you get the base case. The base case got two types, either n is 1 or n is 2. N1 you return A, N2 you return B. Any questions regarding this one? Okay, no questions. I go to the next slide here. So is recursion or iteration better? So basically iteration is better lah. Okay. Usually when smart compiler, when it detects recursion, it will change it into iteration. So what is an iteration? So iteration is basically straightforward lah, like this one here. Okay. So some compilers, some programming languages, it does not support loop. So this is a loop, iterative solution. So some programming like Prolog does not support loop structure. So you have to use recursion. So Prolog you're going to learn, I think, your year 3 if I'm not mistaken. Okay, there's no loop. Okay. So can you use iteration or not to find largest number factorial of Fibonacci? Based on the example you did learn, the answer is yes. Okay. So you actually have two ways of solving it using recursion or iteration. Iteration also can solve whatever recursion can solve. Alright, but iteration is actually better. Alright. There. Restated here, recursive function is also less efficient compared to iterative function in terms of both execution time and memory usage. So if you remember your complexity, you learned last time big O notation. It measures based on time and memory usage. Okay. So iteration is better. So when do you use recursion? Okay, when the obvious solution is so basically don't use recursion when the obvious solution is iteration. Use recursion when the nature of the solution must use a recursive function, or the programming language doesn't support recursion. All right. So this would be the complexity of iterative and recursive algorithm. So you see that this is number of n. This is the addition that's been performed. So if you use iteration algorithm, number of operations done is 15. The recursive algorithm is 25, and it will increase exponentially as the size of n increases exponentially. All right. Now recursion and backtracking. So backtracking is basically we try to find solution by constructing partial solution, and it doesn't go back. It doesn't get the outcome that you want. You reverse. Okay. So the best way is to understand this is to look at the example. So basically here is you want to place 8 pins in a board. So the one possible solution, but that's for our example, we try to reduce the scope. Instead of using the chessboard of 8 times 8, we use 4 times 4. 4 times 4. Okay, so this one is using backtracking. Okay, we're going to use a backtracking method. Alright. It tries to extend a partial solution towards a completion. If the partial doesn't solution would not lead to a solution, then basically when it reaches a dead end, then it will move back up. Okay, so it goes, reach a partial solution. Bila it detects it reaches a dead end, it goes back up. And then remove the most recently added part and try other possibilities. So you put Q here first. Okay, you cannot put here. You cannot put here because it will attack each other. So you put here. So the problem is when you put here, your next option is that you cannot put here, you cannot put here, you cannot put here, you cannot put here. Okay? So what you do is you backtrack balik. Okay. So since Q cannot put here, you move it to this side. So if you move it to this side, then you can put you cannot put the Q here, you cannot put Q here, but you can put Q here. Okay. Alright. So this would be your next solution. This all partial solution lah, tak siap lagi. Now when you put your Q here, you try put Q here cannot, here also cannot, here also cannot. So what happened? Backtrack lah. So this one backtrack. You cannot put your Q here, you cannot put your Q here, you cannot put your Q here also. So backtrack balik. Okay. So masa dekat sini tadi, okay, you dah try. This Q here, kalau you buat dekat sini pun tak jadi juga. Ingat tak? You buat dekat bawah sini pun tak boleh juga. Sini pun tak boleh juga. So dia akan makan by the screen. 1 and 2. So, what's the next solution? This Q, you have to move to the second column. Okay? And then when you move to second column, okay. Then you can, so you put here, the first one here is here. Not here, not here, not here. So you can put it here. You get your Q here. Can you put here? Okay, you can put here. You get this one here. Right? So you cannot put here, you cannot put here, you cannot put here, so you can put here, but all siap. And that is the concept of backtracking. Alright? So for this particular implementation, you can look at the page book 381. Alright? Alright. So, excuse me. So as a summary, basically, you should know the concept of recursion lah. It's a function that calls itself that, but it reduces the size, whereby until eventually it reduces the base case. Alright. So yeah. So basically, this is the summary lah for this topic. So we look at recursion implementation, finding largest number in array, also printing a list backwards. Alright, and then when do you choose recursion and iteration? Or iteration is basically more efficient lah in time and space compared to recursion. If there's a direct solution using that can use iteration method, they use iteration method. Alright. Backtracking, you just need to know the main concept of backtracking lah. It's basically constructing partial solution. If you have a partial solution which is a dead end, you go to back to the previous step, then you redo. If you cannot redo, then you go back up again. Like the queen size puzzle just now, the 4x4. Alright? Okay, that's all for today. Any questions? So, if you don't understand, I suggest you draw it for this example and also for this example. Okay? Just that remember this one here, the printout is actually at this stage. Not at this stage. At this stage, you do not fulfill this condition. Okay? But also remember, when you do not fulfill this condition, you didn't fulfill this condition, this is actually a solution, partial solution to this reverse print. That one you don't forget. Okay? Alright. Okay, any questions regarding Fibonacci? No, yeah? So Fibonacci, I'm not teaching you the maths, I'm teaching you basically the implementation. Okay, in C++. Alright? So the mathematics, I believe you already covered in your discrete mathematics. If no question, that's all for today. I'll see you guys this Thursday for your lab. Okay? The previous lab I already give the answer, right? Can you download the answer? I give you the answer and also my recording. The recording can hear my voice or not? Boleh ya? Okay. Alright. If I got question regarding the lab, you ask me in the next lab, yeah? Or you can ask me now as well. If you got any question.
Good afternoon, sir.
Hi, yes. Who's that?
Wong, I'm Wong.
Hi, Wong.
Okay. I have a question about the assignment.
Okay.
Is that we need to use the for operation to do our assignment?
You need to use what? I cannot hear.
For operations, set to PST file.
Can you type it in your chat, please? Sorry.
Okay.
I look at his chat first. Use file operation to do your assignment. Okay. The data is actually you initialize it, Wong. Not file operation. You mean like the .dat file, is it? No.
Yes.
No. You initialize dekat constructor tu.
So if I cross my program, I mean cross the IDE, so and I'll reopen it, then how I view my old data stored in it?
You initialize it. You put it in a constructor.
Okay.
The value.
Can sir explain the assignment questions? Since I am mainly confused about the questions.
Okay, wait, okay, wait. Let me download the question. Wait, opening the file. Okay. Okay, Wong. Which
Yes.
requirement would you? Okay. So preset, is this the one you are referring to?
Yes, yes.
Yeah lah. So you initialize this in your constructor. So whenever it enters the scope, you get the 5 preset data lah. You already set inside your constructor.
Sir, can you scroll up the screen?
Okay.
Yeah, okay. So we need to add the chicken rice record on this one, the second function, that one.
You mean what? A, B, C, D, E? Which one are you trying to say?
The E, section E, and the second function, that one. Add the chicken
So,
rice.
B, right?
E. Elephant.
E, yeah.
Elephant.
Yeah, yes.
The second function, that one. Add the chicken rice record.
Oh, no, this one, the record basically kan you dah add chicken rice kan?
Yeah.
Manually you display and then the user add his chicken rice, correct?
Yes.
Whatever you order. That one is the view selected. That one will be the view all chicken rice record. Okay.
Yes.
Okay. Oh yeah, I see what you mean. Okay. All right. Let me just have a look back. You
Okay.
add in, then you delete it. Okay, yeah, I understand. Okay, so when you make a selection, your selection, all your selection, bila you select the chicken rice, it should be under the view selected chicken rice record. Okay, this one here. So for this one here, okay, I think you remind me this in Thursday because I need to check with the lecturer that gives this question first.
Okay.
Please come back to me. Remind me to answer this question on this Thursday.
Okay.
Right.
Okay, all right. I understand your your confusion here. So for now, when you make chicken rice everything, right? You make a selection. You will store in this view selected chicken rice record. This view all chicken rice record. Let me just double check with the lecturer first,
Okay. So I have another question.
Yep.
About the UML class diagram.
Yes.
I to sections I.
Apa dia?
iPhone that one.
Yeah, this one. Yes, correct.
About the UML class diagram is about we draw the class diagram only kan? About the class.
Yes, correct.
Class only kan?
Yes.
Class only and other functions such as the menu.
Before you talk about trust, remember you have the encapsulation, inheritance, and basic polymorphism. So this one you need to do by yourself in UML, how to design inheritance,
It's
How
same
to
as the dot set one, right?
Yes.
Okay, okay.
So the,
Thank you.
okay. So the UML. Okay, let me explain here. UML. So
Mhm.
this one you must take into account these properties.
Okay.
Okay. How you design? That one you have to do your research in the internet or the book. Okay.
Sir,
Yes.
sir,
Is that clear, Wong?
Yeah, yeah, clear. Thank you.
Okay.
sir,
All right.
can you,
Thanks.
can you hear my voice, sir?
Yes, I can hear, but not clear
Yes.
sangat lah.
Is Korean motor sini? I mean, saya ada example sini. Boleh sir tengok kat bagi UML diagram?
Okay, jap.
Can I share the screen?
So let me. Can you share? I tak nampak lah.
Yeah. I'm trying to
Okay.
share. Is it something like this?
Yes, betul.
Oh,
But I'm not.
okay.
About the solution, I'm not saying it's correct. It
Yeah,
looks
yeah.
something. Yes, betul. Correct.
Okay. Okay. Thank you, sir.
Okay. Good. All right. Okay. Okay. So Wong, please remind me on your question. I will ask the lecturer after this.
Okay, okay, no problem, no problem.
All right. Okay. Thanks. Thank you for the question. Okay. If no question, that's all for today. I'll see you guys next week. Okay. And next week, like this Thursday. And remember, you got quiz. All right. Okay. Bye, everyone. Bye
Thank
bye.
you, sir.
Welcome. Bye bye.
Thank you, sir.